Okay, so and now we are live sa aking YouTube channel, no? So, i-chat ko na lang dito sa ating chat box yung ano natin, link, no, for the live. Okay, let's start for this discussion about linear programming. Again, this is the last part, the last topic that we are going to have this final term. So, sir, duha lang ka topic pala yung ano natin, coverage ng ating exam niya, dalawang topic lang, the linear programming at saka the logic. I will not discuss simplex method, no, because we don't have enough time. Okay, so let's start. So, what are the learning objectives this afternoon? At the end of the lesson, you will be able to define linear programming. Next, create an equation, which is the objective function. Then solve problems involving linear programming, and also create an equation, which is create an inequality rather, no, which is the constraints of linear programming. To start with, let's have the definition of linear programming. So, linear programming is a mathematical method that is used to determine the best possible outcome or solutions from a given set of parameters or list of requirements which are represented in the form of linear relationships. Actually, this linear programming exists when there is no proper representation of variables noong unang panahon. Di ba sa una, when you were in high school, your teacher taught you how to solve system of linear equation like x and y, ganon. Then also a real life problem using that one. Sa una kasi, yung hindi pa nag-exist yung representation of variables. So paano nga ba nagso-solve yung mga tao noong unang panahon? So they use this linear programming. But the linear programming that we have right now is it's developed, no, na revised na siya, because in this lesson we will represent, no, a variable already. We will not use the old, ang tawag dyan, yung old version in solving linear programming, yung walang variable na gagamitin kasi medyo mahirapan tayo. Linear programming involves a linear objective functions, which is the function that must be maximized or minimized. So in this lesson, in a situational lesson, problem rather, you need to understand what is the goal, what is the objective of this problem. Kaya nga in this statement, no, this linear programming involves a linear objective function that we are going to either maximize or minimize. Kasi in linear programming, there are only two goals. Again, in linear programming, there are only two goals, which is you are going to maximize or you are going to minimize. That's the only two. So depende na siya. And sa problem, you can clear you can easily identify, no? If you're going to understand the problem, you can easily identify what is meant to ask, no? Kung maximize ba siya or minimize ba siya. And also, this objective function is subject to some constraints, which are inequalities or equation that restrict the values of the variables. So these constraints, this will lead us to solve the problem. And I do hope that you can still recall your lessons on inequalities, also in your algebra solving system of linear equation. Kaya it is very helpful no, in this topic. Magso-solve man tayo this topic. Now, here are some of the applications of linear programming. So I am not going to discuss this anymore. So actually, marami ito. Okay. So here, ito din, applications of linear programming in medicine. So at this moment, let's discuss the linear programming model. So we have first the objective function. In a problem, just like what I've mentioned kanina, you are going to either maximize or minimize. That's the only two goals ninyo. That's the objective function. So the objective function equation can be represented like this. Z is equal to C sub 1 x sub 1 plus C sub 2 x sub 2 and so on and so forth. Of course, it was mentioned earlier also that your objective function was subject to constraints. So what are these constraints? These constraints are equations or inequalities. Again, these constraints are equations or inequalities. So, depende kung pila ka buok, no? Kung ilan yung number of constraints, pwede 3, pwede 2, pwede 4, pwede 5, okay? At saka depende na yan siya sa problem. But no need to worry because in my quiz, even in my exam, I will give you 2 constraints lang. Yet, 2 constraints lang ibibigay ko para di na kayo ma-stress. Okay? Again, 2 constraints lang tayo para di na kayo ma-stress. Lahat ng examples ko din, 2 constraints, no, para hindi na kayo ma-stress. So what is this x sub j? That's the decision variables. The bi is the constraints levels. This one, wala siya nabutang, no? Ayun na. Then the cj is the objective function coefficients, and this one, the a is the constraints coefficients. Now, sir, I have a question. Kung na goal na maximize o minimize, mag-matter ba ang symbol na ginamit for constraints? The answer is yes. Now, for maximize, the symbol for constraints are at least. It's less maximize. Wait lang ha. At least, no? The symbol for at least is greater than or equal to. Again, if your objective function is maximize, the constraints is, sorry, baliktad pala, mali akong na-mention, no? It should be less than or equal to pala na symbol. Sorry. Again, kung ang objective function ninyo is maximize, the symbol that you are going to use for your constraints is less than or equal to. But if your objective function is to minimize, the symbol for inequality is greater than or equal to. To realize that one, okay, later I will give you an example. Again, to realize that one, later I will give you an example. But before that, let's discuss now the 3 possibilities of linear system. Again, the 3 possibilities of a linear system, we have 3. The square system, the tall system, and flat system. So each system, I am going to discuss that one. First, let's discuss the square system. Kailan nga ba matatawag na yung dalawang equation mo or dalawang given mo is square system? So the number of decision variables is equal to the number of constraints. That is the number of rows equal to the number of columns. Sir, what do you mean by the number of decision variables? The number of decision variables is itong x sub 1, x sub 2. Again, the number of decision variables, yan yung x sub 1 at saka x sub 2 mo. So there are 2 missing variables that you are going to find, which is your decision variables, the x sub 1 and x sub 2. Sir, what is this, the number of constraints? The number of constraints is yung dalawang given ganin na inequality. Diba? There are 2 given inequalities here. So this example is an example of square system because there are 2 decision variables, x sub 1, x sub 2, and also there are 2 number of constraints. Dalawa ang number of constraints dito. The first constraint is the x sub 1 minus 2x sub 2 is less than or equal to 50. The another constraint is x sub 1 plus 4x sub 2 is less than or equal to 96. Also, aside from having two decision variables and two number of constraints, another way of determining whether this is a square system or not is that the number of rows and the number of columns. Dili ko ka annotate, no? Wait lang ha. Annotate. Yeah, dili ko ka annotate. Okay. Note the number of rows is equal to the number of columns. Wait lang ha. Makita niyo akong PowerPoint, dili? Okay, makita na akong PowerPoint. Di lagi siya okay. The number of decision variables, we have this one, dalawa sila. And the number of constraints we have here. First, ito, constraint 1, constraint 2. Then, the number of rows is equal to the number of column. Diri mo mag-focus, okay? Dito kayo mag-focus, no? There are 2 rows and there are 2 columns. So, this example is a square system. Okay? Next, we have the tall system. Kailan nga ba matatawag na yung given mo is an example of tall system? The number of decision variables is lesser than the number of constraints. Now, how many constraints do we have here? The number of constraints do we have here is 1, 2, 3. There are 3 constraints. However, how many number of decision variables do we have? There are 2 decision variables here. 1, 2. Di ba x sub 1, x sub 2 lang? Di ba ang atong decision variables? So, in this case, if the number of decision variables is lesser than the number of constraints, that means this is an example of tall system. Again, tall system ang tawag. Now, another way of determining whether this is a tall system or not is that the number of rows is greater than the number of columns. Again, the number of rows is greater than the number of columns. How many number of rows do we have? Diba? There are 3 rows. Again, there are 3 rows. 1, 2, 3. Ang columns, 1, 2. So that means if there are more number of rows compared to columns, automatically that is tall system. Or if there are lesser number of decision variables compared to the number of constraints, that is a tall system. Now, let's proceed to the last system. Ito, the flat system. So flat system is kabaliktaran lang ng tall system. Again, the flat system is the opposite of the tall system. So in this system, the number of decision variables is more than the number of constraints. Again, the number of the decision variables is more than the number of constraints. That is, the number of rows is less than the number of columns. So in this situation, there are more decision variables. As you can see, x sub 1, x sub 2, x sub 3, there are 3 decision variables. However, there are 2 constraints lang. So in this system, ang tawag dito is flat system, in which the number of decision variables is greater than the number of constraints. Or if magbabase tayo sa row and column, there are the number of rows is less than the number of columns. So there are 2 rows here, no? Dalawang rows lang. Isa at saka dalawa. Meanwhile, for columns, tatlo. 1, 2, 3. There are 3 columns. So this is an example of flat system. And take note, in the flat system, there is an infinite solution. For the tall system, wala pala. No, wait lang ha. Balikan natin ang tall system. For the tall system, many representative solutions. Again, for the tall system, there are many representative solutions. For flat system, there is an infinite solution. However, for the square system, there is a unique solution. When we say unique solution, there is only one solution involved. Again, there is only one solution involved, but a square system. For tall system, there are many representatives, while for flat system, there is an infinite solution. Now, these are the following steps in formulating linear programming model. Again, these are the following steps in formulating linear programming model. So the first step we have here is you are going to read the problem carefully and, if appropriate, organize the data into table. Second, determine and define variables, and these variables represent the unknown quantities whose values are what you to find. The next step is formulate objective function, but in order for you to formulate an objective function, you need to understand the problem, whether the goal is to maximize or minimize. Next, create or formulate a constraint inequalities. Gagawa kayo ng equation based on inequalities. Next, number 5, solve the problem using an appropriate algorithm or mathematical technique. One way of solving linear programming is through graphical method, no? So graphical method of linear programming is used to solve problems by finding the highest or lowest point of the intersection between the objective function line and the feasible region on the graph. So this method is limited only to 2 decision variables. Again, this method is limited only to 2 decision variables. Okay, so mag-start na tayo solving. Let's have the 10th production. Again, let's start with the 10th production problem. So medyo taas na siya nga problem, no? Yeah, very broad lang siya nga problem. And don't you worry, because I will teach you how to solve this one. To start with, let me read to you the problem. A manufacturer of lightweight mountain tents makes a standard model and expedition model for national distribution. Each standard tent requires 1 labor hour from the cutting department and 3 labor hours from the assembly department. And for the expedition model na tent, it requires 2 labor hour for the cutting department and 4 labor hours for the assembly department. The maximum, take note the clue, it was stated in the problem, no? Nanay clue sa problem, the maximum. The maximum labor hour available per day in the cutting department and the assembly department are 32 and 84 respectively. So if the company makes a profit of 500 pesos each for standard tent and 800 pesos on each expedition tent, how many tents of each type should be manufactured each day to maximize the total daily profit? Take note, the clue is maximize. So your objective function, your goal is to maximize the total daily profit.
Okay, guys, you may leave